Hello from me. I'm David. Very nice to meet you in this beautiful place. After listening to what's ahead of us, I am very sorry to inform you that there is the most boring part of the whole day today, which is my presentation. In my hopefully short talk, I would like to focus on my favorite topic when it comes to Moodle development, which is outputting HTML in Moodle. If you think about it, then outputting HTML is an essential part of any web application. From a certain higher level perspective, and if we oversimplify things a lot, then we can see any web application, any web program as a program that takes some user inputs, generates the HTML, and sends this back to the user. Of course, these days, things get more complicated with asynchronous things and JavaScript and media and these things. But in general, this is how it works. And the way how this is done is what makes particular frameworks very distinctive, and it is what we like on them or dislike on them. It doesn't surprise that as such a key component, it evolved the way how outputting HTML is done in Moodle has evolved a lot during all the 16, 17, almost 20 years of development. So each of these development stages, each of these styles of doing the HTML output left the trace in the Moodle code base. So if you look at the code base, the Moodle big code base now, you still can find examples of how things were done in the past, how things are done now, and sometimes it can be challenging for new developers who seek for good examples of how to do things, pick a good place to look at as a referential one. So when we try to explain to users how to output Moodle in Moodle, it doesn't surprise that sometimes they are quite confused because documentation says you something and suddenly the real examples are different. So what I would like to talk today is to have a quick overview of how the Moodle development API evolved in the time, similarly as this ecosphere or something like that, how it left traces in the code, how all the new layers that were put on top of the old ones, how they interact with each other and everything. So the real title of my today's talk is really the evolution of the output API in Moodle, and I will try to get through it in a quick way, in a kind of overview and overflight mode. If you look at fundamental, really, very old principles that has been present in Moodle since very early stages and very early commits in 16, 17 years ago, we will see that there are three key concepts that are still valid and still very present if you think about outputting HTML or outputting any data really in Moodle, which is formats, text formats, security, and text filters. As you know, in Moodle, we normally, or most users probably use the HTML editor for editing content, be it Eto or some other editor. Eto kind of hides this fact, but in Moodle, any rich text can be formatted in several formats. We support not only the plain HTML, but also Moodle format, which is basically HTML that just does some basic formatting for you. We support Markdown. We support plain text that doesn't do any formatting and these things. In the past, there was also support for wiki format. It was dropped very early and is not supported since then. This format is always stored in the database just next to the field that holds the text itself. So when any user submits rich text into Moodle, it is saved in the database, typically in the message or post or some text field like that. And just next to it, it is common practice to store the format as a number. Each of these formats has a code to know in which format this text should be interpreted. When it comes to security, the second concept when we need to keep in mind is the basic rule number one, really, that we never can trust the input that comes from the user. It's not because we don't trust them or something. It's just securing the site from malicious attacks, malicious content, or even unintentionally wrong data submitted where they didn't apply. And this doesn't apply only to text, but to all cookies, to all other data that comes from the users. As an example, this is a real photo of real thing. If you look at the second line in the address, it's an example of some people. Whenever we see just a form on the page, we just fill it and submit it. There are people living between us who take any form as an opportunity to try whether there is an hole in the system. So they basically try to inject. This is a JavaScript injection attack, basically on some address form. The third concept we need to keep in mind is text filters, and you know that filters are basically plugin type in Moodle, and administrators can choose which filters they want to enable in their sites, and they also choose a setting whether the filters should apply to content or content and headings. And we will see shortly how this settings actually applies, how we work with it and the code. Moodle, since the very early versions, has several helper functions that help us to output, and many of them are still used. One of the oldest one is a very elementary S function, which was originally introduced as a O function and later renamed, which was introduced in very early Martin's versions of Moodle. All these functions did things like output variable or print variable or output or print and things like that. And this is one of the remaining relics of these times. We can imagine it that S is basically a Moodle wrapper around the standard PHP HTML special characters function that basically replaces HTML special characters like these brackets with HTML entities and quotes and things like that. The other method that we still use is format string. It is supposed to be used for displaying short texts, typically one-line text, that do not contain any rich text formatting. So they should not allow paragraphs or headings, things like that, but we need a single line of it. The distinction between a format string and previous S is that here we want to apply the filters, including things like multimedia, multi-language filters, which actually does contain HTML text, but they are removed before printing this thing. So this function was introduced as a part of introducing filters, and it is still used in Moodle. The third function I would like to mention is format text that is used for formatting blocks of text, really. So once you have rich text that already contains some paragraphs and things like that, and we still need to apply filters on it, so we use this one. And the last one I want to mention is cleaning, is a function that cleans the text, which relates to that security I mentioned. It basically removes all the nasty tags, attributes, JavaScripts, and things like that from submitted text. And it does it in a pretty clever way that it decomposes the text into individual nodes in the DOM structure, filters all the nasty things away, and just puts all these nodes together into a new HTML again. This cleaning can be sometimes skipped, not applied, which is used in certain situations, typically when the code explicitly says, I don't want this place to be cleaned. There is a no clean parameter that can be used. Or when a so-called trusted text subsystem is used, which is again a big chapter of how the output can be used. This trusted subsystem is used at very few places in Moodle. I think only Forum does it at the end. It didn't spread to other places. It actually allowed, or the idea behind it was to allow administrators to define roles and certain users who are trusted to put things like Flash and JavaScript and this interactive content into their HTML content, and it wouldn't be cleaned for them if they were the authors of the content. I tried to put all these relationships and consequences and things like this into kind of a guideline of which helper function, which style of outputting the output should be used in which situation. So there is kind of a decision tree you can make here. At the very top of this, you must decide whether you want to support rich text or not, whether filters should be applied or not, whether the text contains user data or not, and depending on the situation, you end up with one of these styles of outputting the content. So typically we use the S function for things like plain text, the code of a program, or when we are outputting the attributes of HTML text, the within one. We use format string for things like activity titles on the course front page. We use it for forum post titles, subjects, and things like that. The only place where we can use plain echo without any cleaning and formatting is when the text does not use the user data, because then we know that the security is fine. So typically for language strings. And we use format text with particular options depending on whether we want to allow JavaScript and things like that be present or whether we want it to be cleaned. At the end of Moodle 1 phase or time, just before Moodle 2 was about to be introduced, the weblib library that was presented in the core was full of functions and helper functions to display particular elements of the page, things like headings, titles, user pictures, navigation, error notices, and things like that. There was a big demand from themers and from the community to have much more control over how all these things are rendered, how they look like. Themers no longer were happy with only changing the CSS of the existing HTML structure. There was a demand to be able to change how the actual HTML is generated for all these headings and user pictures and things like that, which took us and Moodle in around the Moodle 2.0 release into a new rewrite of the whole output system, and we came to a new era of Moodle, where some of these concepts like global variables page and output and HTML writer, renderers and renderables come from. I will very shortly introduce each of these, asking you to actually study more details in the developer documentation. So one of these essential components or classes that is used since Moodle 2.0 is a global variable page, which holds the information about the current page as it's being rendered and sent back to the browser. It holds all the information, like the URL of the page, the heading of it. It has the information about the blocks that are present on the page, what is the context of the Moodle context of the page, what is the layout of it, and things like that. This global page variable is basically an instance, singleton instance of a Moodle page PHP class created automatically by Moodle core during the bootstrap initialization of the request handler. For us, it is important to know that through this page, we get access to the actually used theme on that particular page. As you know, each page can have different themes depending on conditions. And through the theme, we can get to renderer. Now, these renderers are basically nothing more than just a class that provides some methods that actually return the string with HTML representation of something. These renderers replaced all these hard coding functions in WebLib, like print heading and things like this. We basically have some core renderer that is part of the Moodle core as well, and each plugin can come, and most of them come with their own plugin renderer that is responsible for outputting things relevant to that plugin. Renderers can be further overridden via a theme, which is that mechanism that all the themers asked for. So even if a plugin or a core comes with some default way of rendering the output, any theme can come and say, okay, I will do things differently, and this widget, this particular part of the page, will be rendered my own way. One example of a renderer that you might see very often in Moodle code is global variable output, which, depending on what the script does and what kind of script it is either instance of a core renderer class or some other subtype of it, like in this example, core renderer CLI for command line interface. So if we have a very same line, same code, in this case, we are echoing an output or return value of a heading method with some parameters. So if we are on a normal page, this output would return HTML with a heading, H2 heading. If we are in a command line script, it would change the way how it outputs things, so the very same call would be the very same heading would be displayed in a different way. And again, themes could change things further and everything. If you, or when you look at existing examples of how renderers are done and implemented both in core and plugins, you will recognize two major ways of how these rendering methods can be organized and implemented there. They both work the same way. That's why I try to explain it via these parallel options. And you should be aware of both of them and know when to use which. The first style of organizing rendering methods in the renderer is to implement all these things as a public methods with multiple parameters or 0 to multiple parameters as needed. So this is just an example of such a method. Let's say there is a public function somehow named like summary table that takes all the data it needs, and this public method would return the HTML with representing that thing. You will see this style of organizing in, for example, this core renderer. So we have all this heading, header, and footer, and all these things implemented as public methods. This is how we use such a renderers then. You can see on the first line, I basically ask the current page to give me an instance of some plugin renderer that will be responsible for rendering these things, or my things. And I know that this particular renderer should have a public method called, in this example, summary table. I will feed as many data as needed to this method, and it will render it. The other style that you can see in existing examples is using renderables. In this way, in this kind of using renderers, you first need an object that represents the thing that is being displayed, rendered. That's why we call them renderables, which is basically an empty interface in PHP. So first we create an instance of this renderable class, and the renderer itself consists of protected functions, not public functions, but protected, that are all named with a pattern. They start with render underscore, and then there is the name of that renderable thing that they are responsible for. They take the single parameter, which is the instance of that renderable object. It's the contract that is the rule that is followed. This style was supposed and is encouraged to be used in actual plugins rather than in core. And this is how it is used then. So in this case, you see that first I create a new object, in this case this summary table. Depending on what that object needs, I can set up its properties or call some methods or do anything. As long as it is a renderable object, I do all the data on it. And then I pass this renderable instance as a single parameter to my renderer, which has a general render method. And this render method is implemented in a way that it looks at the name of the class of that thing, it takes that name, puts a prefix render underscore to it, and looks up or looks for the protected method that implements the thing and does all these things for you. So to summarize, this renderable is nothing more than just a data carrier, the holder of the data, that basically kind of defines the interface between your business logic and the rendering layer, this view. So whatever is needed to be rendered should be obtained by this data. The way how you actually implement this renderer is up to you, whether you will have some setter methods, getter methods, whether it will be public properties, it's up to you. Actually, within the functions, either style, to actually generate the HTML, instead of hard coding it, it was very common to use this utility class HTML writer, which has helper methods and helper functions to do basic things like outputting tags and divs, pens, links, images, and things like that. Among other things, it automatically uses this S function that I mentioned before to escape all the attribute values. So when you generate something which has some value of the HTML attribute, it automatically wraps it with S and little things like that. The problem with HTML writer was that it appeared at the end to be a very clunky way to do pretty simple things. If you know, even elementary things like display a div with little content took like this long line because you had to call HTML writer double column, tag, div, array with classes and all these things, and it felt really heavy, you know, to do these kind of things, especially when it came to producing nested structures in HTML. You know, one div, some subdiv, paragraph inside it, list inside it, and these all were then combined with kind of HTML parameters, and it was really ugly way to do these things. So it doesn't surprise that themers called for doing the simple things simple way. You know, why should I need to learn HTML object-oriented, you know, things just to produce HTML? I'm an artist, I'm a designer, I want to do things easily. So after we left from having HTML hard-coding in the code, got rid of it and replaced it with HTML writer, now we were slowly going back to actually having or finding a way how to have this HTML easily defined in the Moodle code. Which takes us to the third stage of where we are currently with Moodle. And we are introducing Mustache templates and template tables object. These mechanism, this style of output is basically built as a layer on top of renderables and rendering functions. So you have to understand how rendering and renderables work. And what we do now is that this API is that it allows you to define the actual HTML fragments in native HTML templates, where we use the plain HTML structure with some certain bits of it being using special syntax for things that will be filled during rendering through this template. So in this case, for example, the first thing, this unique ID value, if I combine this template and I give it a data structure that contains a unique ID property, so the value will be used and put into this template will replace this method. There are some other simple syntax for things like looping or going in a loop through some structure. So for example, this is a way how we could define or generate a list of things. I will not go into big details. There are, depending on how many curly brackets you use, you end up with either having or not having the value escaped. So depending on which kind of escaping you use in the Mustache, you are or you are not supposed to use this as or format text or format string when you are populating the data for the Mustache. So it's all these principles that existed before are still in place. You can't simply ignore it, and you still have to understand which of these functions should be used when. So template was that Mustache file with the HTML, and next to it we need the object. We need something that provides the data for the template, something that holds, that will give us the values that we will use to fill into the template. For these things, we need to, that object needs to implement a template table interface, which prescribes you to implement a single method, which is called export for template. And this export for template should return a simple data structure that can be used for that defines all the values that will be put into this template. And when you combine them, we get this actually output. Sorry. So this is just an example. Again, something similar. We have this widget that implements the renderable thing because it is something that we can render, and we also support rendering it through the templates. So in the renderer itself, where we previously would have something like, take the widget and produce the output with HTML writer or something like that, we simply delegate the actual outputting the HTML to rendering through the template. So that is where the templates become as a layer on top of these renderers, because instead of using HTML writer within the rendering methods, we delegate the rendering to rendering from templates. So first, we ask that past widget to export its data. Show me all your data, describe yourself, in plain values. And then I take this data and pass them to another function, render from template. I specify which template should be used. This gives me the HTML structure and what data should be used as a context for that template. And the Mustache engine that we use, either in PHP or JavaScript, that's one of the benefits that we can finally render things either on the server side or the client side and get the same result in both cases, will actually produce the HTML and we can then use it. So the rest is the same as it was before. So this way you basically can go and replace all existing rendering and renderers that you had before to support templates. To make things easier, because you can imagine that this middle part you basically have for every single thing, you just repeat it over and over again. In all the cases, we just, hey object, export your values, and I will use this template to use it. So we introduced something called implicit rendering method, which simplifies things a bit. So in this case, it is enough to have this renderable and templatable widget, an object that is able to export its values. And if there is a template file that is named same as the templatable object, when the name matches, like this widget in this case, I don't need this render underscore widget method anymore, and this will just work. The method, the renderer will find that Mustache template, will apply the exported data, and it will just work. So this is probably the simplest way how it's happening, and all what I was trying to explain was what are all the layers below it that are needed to make this actually happen. So at the end, all these complex systems, all these layers and everything, it's sometimes wonderful that all we actually try to do is to get a very simple output at the end, and we somehow just tend to get very simple output, but using a lot of spec behind it. So that was everything for me. Thank you very much.